Welcome to queenon7.com. Please like, share and subscribe my video. Today we're going to look at the giant covalent structures. You remember in the previous video I have already explained how covalent bonds are very strong between the atoms, but intermolecular forces are very weak, so they have a very weak melting point and boiling point. Some of the giant covalent structures are made by the non-metals, but because they are making a joint structure, so they have high melting point and boiling point. And the great example we're going to use today are diamond, graphite, and we will use silica oxide. Diamond and graphite, they are actually pure form of carbon. They do not have any other atom, so they both are pure carbon. And we will see what is the difference between them. Now diamond, this is carbon. It is attached with 4 other carbon atoms. In graphite, it is attached with only 3 carbon atoms. Carbon belongs to the 4th group. You do know that if you look at the periodic table. It belongs to the 4th group and it has 4 electrons in the outer shell. Out of 4 in diamond, carbon has utilized all 4 electrons to make a covalent bond. Whereas in the graphite, it has only utilized 3 electrons and 1 electron is actually available on each carbon atom like this. Now, what's going to happen is we're going to look at the properties. The examiner is actually asking you how you going to explain the structure of diamond and graphite, and how you're going to link that with the properties. That's how you will be asked to answer the 6-marker or 5-mark questions. So diamond do not conduct electricity. Yeah, it doesn't. Why? Because for electricity you need free moving electrons or charges, which is not present. All 4 electrons are being utilized. So why it doesn't have free moving electrons? So does not conduct electricity can be explained by this explanation. It does not have free moving electrons. Job done. Also, why it is so hard? It's hard means high melting point and boiling point. Diamond is one of the hardest substances on the Earth planet, and that's why we use that for the drilling or cutting the rocks. It is hard because each carbon atom is attached covalently, or I would say, I'll make it simple for you. Each carbon atom made 4 covalent bonds with 4 other carbon atoms. That's why it will make a giant covalent structure. So the covalent bonds are very strong because of the giant covalent structure. It has a high melting point and boiling point. Okay, let's talk about the graphite. Graphite, on the other hand, has got 1 electron free on each carbon atom. So it has 2 properties. 1, graphite is slippery and it conducts electricity. Electricity and heat, both of them. It does have high melting point and boiling point because it still have joint covalent structure, but it conducts electricity as well. It's not hard as diamond. Let's take an example, take an explanation of slippery. Why is it slippery? Each carbon atom obviously attached with the 3 carbon atoms, and they will make layers. 1 layer, there's another layer and another layer. If you see in your books, you will see their layer. Between the layers, so if I make another layer there. It is slippery because it contains layers. Its shape is hexagonal shape. So it contains layers that will make it slippery. Why? Because they have weak intermolecular force. So this one is actually shows you it has weak intermolecular force between the layers. Now here I would like to make a point. A lot of GCSE students, they try to write out it has a weak bond between the layers, which is incorrect. If you write down weak bond, you will not gonna get a mark. So you need to actually mention there is no proper bond. For the bonding, you need to share an electron or transfer an electron. And none of these are actually applicable in this condition. These are just like an attraction. It is not a proper bond. So you will say intermolecular between the molecules. If you do not remember this word, just say there are weak forces between the layers. That's why it is slippery. It can slide. So weak forces between the layers, hence it is slippery. It conducts electricity. Again, the same example we have used in the metallic bonding. So you can say it is slippery because of the reason it has a free moving delocalized electrons. That's why they can move around the whole structure and conduct electricity. One more thing I would like to mention, like just carbon in diamond. Each carbon, if they ask you to actually explain the structure of graphite, each carbon is attached with 3 carbon atoms via covalent bond. So you need to write that in graphite each carbon atom is attached with the 3 other carbon atoms via covalent bond. So in summary, you can take a screenshot, or you can actually write down. If you want, you can pause it and write down these properties. And this is how examiner is expecting you to write down the answer about the structure of graphite and diamond. Now silica oxide is the last one. I'm just going to remove this bit. Silica oxide, it has got 2 different atoms. So it has silica, which is just under carbon, and it has oxygen. Now they also make a very big long structure. So if you look at silica, it will carry on making the structure like this. So it's a joint covalent structure. Silica oxide they use in the blast furnace where they actually do some sort of burning or combustion of the other materials. And because they are very solid, very strong, so they use this as a base for any those combustion reactions. Silica oxide also make a giant covalent structure. Each silicon is attached with 4 other oxygen atoms in the giant covalent structure. So if you are asked about the silica, please do make sure that you do remember silica belongs to the 4th group, just under carbon. It can make 4 bonds. Normally it actually make silica like carbon dioxide. It makes a bond silica oxide like that, but in giant covalent structure it will actually lose those double bond and will carry on connecting with the oxygen. Can I quickly make another point about the graphite? Graphite are actually used in the lead pencils. Lead is a metal. It has never been used in the pencil. The first time they have found the graphite, its color was actually, it looks like it was actually lead when they found it near the lake. And they started using it because it was slippery. So that's why you can use in the pencil. You can use in the lubricants because the layers can slide. So they started using it, but they are still calling it as a lead pencil. But there is no lead in it. Lead is a metal which cannot actually work like graphite. Right? Thank you very much.